Hello everyone, welcome back to my tutorial. In the last tutorial we have seen how to use a partition to specify the 3D assembly. If you have a two object, we can how to use a partition. For example, just go to the second slide. So instead of creating a contact here, we have a two objects, steel and aluminum. Here we have created a merge nodes, a similar nodes here to transfer the displacement and stress everything. But in this tutorial we are going to use a glue contact. So here we are going to apply a contact which will glue these two surfaces. Okay, so by seeing the problem, ours is a stepped bar. One is made up of steel of Young's modulus 210 gigapascal and Poisson ratio is 0.3, which is isotropic material, and aluminum material having Young's modulus of 70 gigapascal and Poisson ratio is 0.33. So we are going to do linear static analysis. So the difference is we are going to apply a glue contact here. So here there is a cross section and here we have a cross section, and 1000 Newton force we need to apply at the right side. We just want to apply it. Here we need to fix it. So this is the problem. This is the analytical result. We'll check with the finite element analysis result. Now just go to Salome. So first go to geometry. So two objects we need to create it. First one is the steel one. So having cross section of 0.2 and 1 meter length. So 1 meter length. This one is 0.2 and this one is 0.2. Just apply it. And the second body, same 1 meter length. This one is 0.1 and this one is 0.1. Just right click. See, this is the first body, this one is the second body. Apply and close. The same thing, I just want to move this object to this mid position. Just select this box to go to operation, transformation, translation. You have selected box 2. Here I just want to move it to in x direction 1. Here the total length of the body is 0.1. I just want to move mid. That means 0.05. Similarly here 0.05. Because total length is 2. This length is 2. This is having 1. This side 0.5 I just want to keep. This way 0.5 I want to keep. Same we have got. So just untick this one. Otherwise we will get one more object. So just apply and close. Now we have got this two object. Now what we want to do is we want to mesh it separately. This is the box 1. So just go to create group, volume group, select all. We have only one volume. This is just make it steel. Apply it. Now we have created steel group. This is to apply the material property as well as that will be used for applying the contact. Now just go for this one. So this surface is not required. Now this surface you just choose, select. Here I just want to apply fixed boundary condition. Just name it as fix. Apply it. Now the first material volume body we have created. The surface to apply the boundary condition, that also we have created. Now instead of main shape, just go to box 2. Otherwise just close this. Now select this box 2, go to create group. So the first box we have created these two groups. The second box, this one is aluminum. So just select all, create AL. I'm just giving AM. Apply, and here this surface we need to apply contact. Just add this one. Just give a name called slave. Apply. Why? Because you see, so one is a master. We have not created any master surface. We can see here. So in glue contact and code aster is the master should be volume and slave should be surface. So the master we can use steel, slave we can use this one. Otherwise we can name it also. Now we just want to name one more group, that is load. Load, apply and close. For easy understanding, I am giving one more group, create group, volume group, fit to screen, select all. I'm just making this into master. Apply and close. Now see, this volume group is the master, this is the slave. So this volume is glued with this surface. That is the way it will do. Okay. So that is the way the code aster will solve the glue contact. So now we have created all the groups to apply the boundary conditions, load everything. Now we can go for meshing. Mesh. Now select this box one, mesh, create mesh. So now I'm going to create with Legend tetra mesh. So we can go for simple, that is easy actually. Simple parameter, only specify the local length, some 4 I'm giving. OK, apply and close, right click, compute. So now we have created 3737 tetra element, that is a linear element. Now select this box to create mesh 2. Mesh 2. See, this is the mesh 2. Again go to NetGen. Simple parameter keep the same, or just make it some 3. Create some fine mesh. Okay. Because we have used the same one. Compute. Edit mesh. This is make it 4. OK, apply and close. Compute. Close. Edit mesh. Create another simple one. Simple parameter 2. Make it some 0.2. OK, apply and close. Now you see the mesh one is not damaged, not affected. So now we just compute it. Now see, there is no node connections, elemental connections between the first body and second body. So in this way, what we are going to do is we are going to apply glue contact between these two objects. So to transfer the displacement, I mean force and displacement, everything. So the both mesh 1 and mesh 2 we have done. All the groups are came here. So there are two ways we can do. We can take this mesh 1 and mesh 2 separately. We can assemble using command. We can use the code aster command to assemble it. Another option is called as compounding this mesh. That means select the mesh 1, press the Ctrl and hold and select the mesh 2. This both the mesh we can compound it here itself. Go to mesh. So build compound. The fourth option you can see is build compound. That what it will do, it will make that two mesh into single mesh. Nothing it will not do, it will combine into single mesh. That is the only way it will do. Just apply and close. Now see, so all the groups are come into a single, and right click, compute again. Go to mesh, compute it. Now just I only show this one. So this is the new mesh. This new mesh having both the meshes and both the groups, fix, slave, load, steel, master, aluminum, everything it has. I'm just hiding all. This is steel, this is the master, both are same only. Aluminum, this one is the load, this one is the fixed, and this one is the slave. See, so every groups are came into single one, and we have single mesh group, that is compound. Now we can save this file. Go to file, save as, pictures, code aster. I'm just saving here glue contact. Save it. Now I have saved this file. Now just go to aster study. Every procedures are same for previous object. Only thing is here we need to specify glue contact. Add a stage. First we need to read the mesh. Our mesh is not the mesh 1 and mesh 2. Our mesh is compound mesh. Choose this one. Mesh MED format. Apply. OK. Now just go to define material. So defining the model as finite element model. Here all are, we can go for all. Mechanic 3D. OK. Apply. Save. OK. Now we have done defining the model. Now we need to define the material. Define the material. First we need to define steel. This is the linear isotropic material. So 210 e power 9. This one is 0.3. We need not to specify density because this is linear elastic isotropic material, and also a static analysis doesn't require, only two properties required. One is Young's modulus, another one is Poisson ratio. If you are doing dynamic analysis, then only we need to specify density. Just go to OK. Apply. Save. OK. Now we have defined steel material. Now we just want to define one more material is called as aluminum. Al, linear isotropic. This one is 70 e power 9, 0.33. OK. Apply. Save. OK. Now we have defined the material. Then we need to assign the material to the mesh. Go to material, assign material. Now just keep this name. I'm not changing anything. So mesh model. Here we need to create two options. First one is for steel, another one is for aluminum. Anyway we can specify. We need to include that. We need to assign it. Not the everywhere. Go to group element, edit, choose the steel, this one, save. OK. Here just choose the steel, save. OK. Apply. Yes, no, because we are not finished it. The one more aluminum also we need to specify. Go to edit, group element, edit, aluminum volume, save. OK. Here we just choose this into aluminum, save. OK. Now we have done everything. Now we can go for apply. So if it is red color, it shows that there is incomplete or error. Now it is incomplete, just apply. Now it is become complete. For steel volume we have applied steel material. For aluminum volume we have applied aluminum. This is the command it will generate at the back. Save. OK. Now we have assigned the material. There is no function in our case. Go to boundary conditions. So assign mechanical load. Just keep this load. Now just go for force info. This also we can use. Sorry, this is not required. Force info, edit, group element, fix. OK. Just fix only 3D area freedom, x0, y0, z0, because this is the volume element. Need not to specify this drx, y, z. Save. OK. Now we have fixed here. Then we need to apply load here. For that just scroll down here, or we can force. What it will do, it will filter the force commands. Now force phase is the thing we need to do. This is force at the node. This is force at the edge. Now I just want to apply force at the face. Edit, group of element. Here you can see load is the force name, FX direction. Here whatever the force is applying is a pressure. This command will apply as a pressure. So here we need to apply 1000 Newton. That means it will apply as a pressure. For that we need to apply it as a pressure value. Go to variable. So you can give me any name. I'm just giving force 1000 divided by 0.01. This is the value. Then save OK. Now it has taken. Save OK. Now we applied the force also. But here there is no node connection to transfer the force to the second body. So for that we need to give glue contact. So for glue contact there is a command called listen mail. This is a glue contact command, listen mail. Just tick this one, listen mail, and click it here. Go to edit. So there is one is master and another one is slave. So for that what we want to do is, so master has to be a volume, this volume, slave has to be a surface. Now we have created that. These two things we need to specify. First one is edit, master has to be a volume. Save OK. Slave, go to edit, slaves has to be a surface. See, surface. So this is the master, this surface is the slave. So save OK. So now we have done specifying the contact. This is we can edit and we can keep it as it is also. It will do the glue contact. So the type of the contact is massive. Massive is nothing but solid. So cohesive is nothing but shell. One cell surface is contacting with the other cell surface, that is cohesive. Cohesive means cohesive and massive is nothing but one cell surface is contacting with the solid surface. The first one is master, another one is slave. Here both are solid, that's why massive. Here massive and cohesive is nothing but solid. Master is a solid, slave is the cohesive. That is the way. In our case, the current case is massive. That's why massive is coming. Choose this massive. Now save OK. Apply. See, this is the command. Now we have fixed one side. We applied the force. We applied the load. Everything is coming in the single command. It will write in the single command. Load. Okay. Say apply. Say OK. Now we have done applying boundary condition, everything. Now we need to pre-analysis. There is no pre-analysis here. Just skip this stage. Go to analysis. We want to do static analysis. Go to statics. This is the static linear solver, meca static. Just keep this name. First we need to take material property into the solver. Then model, what type of model it is. Then loads, boundary conditions, everything. So load. Save OK. Save OK. Now we have defined the solver. Then we need to calculate the stresses, because it will calculate on the primary variable displacement. To calculate other values, go to calchamp, name, give the name of any value, but I'm just giving wrestling the same value. Here we can go for sigma, directional stresses. Here we can go for equivalent stresses. So we need to choose here meca static. From the meca static it will calculate. We can choose model, material, everything. It's done. Now say apply. So it's repeated. It's showing error is called SAEQNO. 2 times I have given. just change this into actually LNO. SAQ LNO is means criteria 1 means stresses, stress gas stresses, principal stresses in element as well as node. Now we can go for apply. Now it has taken, you can see here. Just save OK. Now we have calculated the stresses. This one is for only fracture and fatigue analysis. So leave this one. Go to output, save the results. Now just click these 3 dots, go to pictures, code aster, bonded contact, glue contact. I'm just saving this file into result123.rmed because I have already result file. So same file I should not give. Take mesh, take the not the mechastatic results, take the Colchamp result. Okay. Remaining thing you keep it same, save OK. Format to make it MED, just OK. Now we have created every setup. So you can see this is the command file. Now you can save it. Just go history view, click this plus button, click this one, go to 5 seconds and solve this one. So now you can check it, the folder where we are saved it will create the files, number of files. This is the study12. It's the file it's generating. So run case is running now. See, this is the mesh script message file, command file. I think it is solved. See, it has solved. So this is the message file. See, message file, export file and log file. All the file it will generate here. This is the command file. Whatever the setup we have created is that setup. So the start force value, read mesh, what type of analysis it is, to material property, assigning the material property, master, slave and boundary conditions, solver, post processing, saving the results in output. So now we have done. Now we can view the results in paraview. Just go to paraview, open, result123rmd is the front file. OK, save OK. See, Teslin SAQL no is nothing but elemental stress. Okay. Now go here, displacement. So to see the displacement in x direction, see 1.5 e power minus 6. Whatever the displacement we have got in previous case, the same results only we are getting. So displacement in aluminium is 1.4 e power minus 6. Now we are getting 1.5 e power minus 6. It's very close value. So we can go for stress also. So here the stress is C. Here we are getting the maximum stress because of the contact. Just leave this contact. Only check the results at here. This value is around 1. So 1 e power 5. The same value we are getting. So to see the results in plots, just go into rainbow, blue, apply, close. Make this into 12. See the stress here. This value, this color is matches with this color. Or if you want to see the stress only here, just go to element, select this element, go to search option, filter, go to filter, search, extract, selections, enter it, just apply it. Now just go here. There is different options are there. The bottom one is called as rescale to visible range. Now see, this stress value is 1 e power 5. That is the value we are getting in aluminum, 1 e power 5. So similarly we can check with the steel also. So similarly for von Mises stresses, see there are different stresses: von Mises stresses, stress curve stresses, principal stresses, principal stress 1, principal stress 2, principal stress 3. So different stresses are there. Now this is a steel. It's a ductile material. I just want to say von Mises stresses. Go here, apply, rainbow, blue to red, apply, close. Now we have used this one, rescale visible range. That's why it's showing that way. Rescale to data range. This is a manual data we can give. Automatic rescaling. Now we can go with the full model. So just add and view this full scale. So now we can go for this one, all over the time step. So default view. So now we have got, this is the von Mises stress. Similarly for von Mises stress, this value is coming here. To check with this value, here you can go with here, almost here. So or we can go for hover point, place it here, check with the result. See the von Mises stress is 24997. It's little changing, 25014, almost very close to the analytical value. Sigma stress also 25016.3. So all the values are coming here. We are applying glue contact, that's why we are getting some stress concentration here. So here we are fixing, that's why we are getting stress here. So we have learned in this tutorial, we have learned how to solve stepped bar using glue contact. So please follow my videos for more kind of cases. Thank you for watching my videos. Please subscribe my channel for more videos. Thank you.